Hello everyone. The topic for today's lecture is pseudocode. Today's lecture is slightly different from the last two lectures. I'll be giving you a lot of cues in order to pause the lecture video and to go complete a specific problem. If you're watching this lecture on your own time, please make sure to follow the cues. If you're watching this lecture as part of the live stream, I'll be pausing the lecture video for you. So what are we going to do in today's lecture? We are going to go through a set of problems which are part of today's lecture worksheet. Go to the course website and find today's lecture entry, which is pseudocode Jan 29. You'll notice that there is a link to worksheet. There are two different versions of the same worksheet, which are PDF and docx. Since I'm recording this video on my Apple iPad, I'll be using the PDF version. If your laptop or your tablet device enables you to write on a PDF, please go ahead and download the PDF version. If not, please download the docx version. Pause the lecture video here and make sure to go through the download process before you proceed. I'm going to use the markup tool which will enable me to write on the PDF. Let me get started by introducing you to the term pseudocode or algorithm. Pseudocode or algorithm refers to the fact that we have a set of step-by-step instructions to follow while trying to solve a particular problem. So you might be wondering, why are we talking about pseudocode before we learn how to program? A lot of new programmers find it extremely challenging to decouple the pseudocode thought process from the actual programming process. The programming process involves you to take the pseudocode steps and convert that into Python syntax. What exactly is syntax? Syntax is nothing but the set of rules which you need to follow in order to write code in a specific programming language. Examples of syntax rules would be where can you use parentheses, or where can you use curly braces, or should you be using upper cases or lower cases? Should you have a tab indentation? Should you be using a colon, and so on? We are not going to worry about syntax of Python programming language just yet. The focus of today's lecture is on pseudocode so that you can understand how to follow the step-by-step instructions given pseudocode for various problems. While going through these set of problems, we are going to try to understand the high-level concepts in control flow and state. For every problem, you'll have three major sections. The first section would have a box associated with a label name and some value inside the box. The second section will be the code section, which gives you the step-by-step instructions or the pseudocode. The third section is the questions section. I'll be going through some of the questions in the questions section. Let's get started and go through problem number 1. Problem number 1, step number 1 says, add 1 to the X box. The X box here contains a value of 10. So let me go ahead and add 1 and we'll end up with 11. Step number 2 says add 2 to the X box. So we are going to end up with 13. And step number 3 here says double the value in X box. So you're going to end up with 26. That kind of answers question number 1 here. Let's talk about a hypothetical situation. Let's say that one of your friends got a different answer, 24, even though they did follow all the steps in the algorithm. Can you think of a way that somebody could have ended up with an answer of 24 despite following all the steps in the algorithm? Pause the lecture video here and think about that question. One such possibility would be if your friend swapped step number 2 with step number 3. Let's see what happens when we do that. We initially start with 10, and then step number 1 will add 1, which will end up changing the value to 11. Now step number 2 says double the value in X box, so you'll end up with 22. Step number 3 says add 2 to the X box, so you'll end up with 24. The key observation here is that the general case in programming is something which is called as in-order execution. So what exactly is in-order execution? In-order execution refers to the fact that you need to execute every step exactly once and in the provided order. There are going to be exceptions for in-order execution, and we are going to discuss 3 such exceptions. So I'm going to add a placeholder for all 3 of those exceptions, and we'll keep populating the exceptions as we go through the problems. The next problem which I want all of you to go through is problem number 3. Pause the lecture video and go through problem number 3. If your final answer in the message box was hello Ada Lovelace, then you had the correct answer to this particular problem. How many of you wrote down hello Ada Lovelace without any spaces in between? That would be the precise output that you get out of this algorithm. Some of you might have written down hello space Ada space Lovelace. That's because you're human beings. You would have understood that somebody who wrote the instructions here would have meant to have a space between hello and Ada and Lovelace, and that's why your brain would have added the space in. Unfortunately, that's not how things work in the world of computers. You need to give very precise instructions to the computers, and computers follow instructions in a meticulous manner. So if you really wanted space here, that should have been part of your algorithm. So let's go through the steps here. Step number 1 says add the value in first to the value in message. The value in the first box says Ada, and the value in the message box says hello. There is no mention in this particular step that you need to add a space in between the contents of the message box and the content of the first box. And the same thing is true with step number 2. Step number 2 simply states add the value in the last box, which is Lovelace, to the value in the message. So, do you know who Ada Lovelace is? Ada Lovelace was the very first programmer. She took her colleague Charles Babbage's analytical engine write-up, and she came up with the very first algorithm which she published. So she's considered as the very first programmer. Who is Charles Babbage? Charles Babbage was the father of computer science. He came up with the design for analytical engine, which pretty much covered all of the computer designs that we have nowadays. So let's move on to doing problem number 4. Go ahead and pause the lecture video here and go through problem number 4. If you ended it with the answer as 4 in the ABS box, then you had the correct answer for problem number 4. Let's go through the algorithm here. Step number 1 says if the value in X box is negative, continue to step 2, otherwise skip to step 3. X has a negative value, so we are going to continue to step 2. Step 2 says multiply the value in X by -1, so you're going to end up with 4. And then what does step 3 here say? Step 3 here says that we should copy the value in X box to the ABS box. So you end up with 4 as the final answer. What if the initial value inside the inside the X box was 4? Think about what would happen then. Step 1 here says that you need to check whether the value in X is negative. It is not, so it says skip to step 3. The key observation here is the fact that there is a skip as part of the instruction. So step 3 here says copy the value in X box to the absolute box. So you'll end up with 4 as the final answer inside the ABS box here. So what do you think this code is trying to do? Pause the lecture video here and think about the answer to that question. So if you were thinking the code is doing absolute of a number calculation, then you had the correct answer to my question. What did we do to convert the algorithm to this objective? We thought about what is the final answer that we are getting by going through a couple of example executions of the code. The algorithm itself gives you the detailed steps that you need to follow. What I wrote down now is the general objective or purpose for your program or the pseudocode here. Let's move on to problem number 5. Pause the lecture video here and go through problem number 5. Let's go through the steps. Step number 1 says if value in age is less than 0, continue to step 2, otherwise skip to step 3. Value in age is 150, so we are going to skip to step 3. Step 3 says if the value in age is more than 125, continue to step 4. 150 is more than 125, so we are going to continue to step 4 here. Step 4 says put too old in the message box, so that's what we will end up with after executing this particular pseudocode. What do you think this code is trying to do? Pause the lecture video here and think about the answer to that question. So if you were thinking that this code enables you to verify whether the age box has the correct data or not, then you had the correct answer to my question. What is being done here is something which is called as bounds checking. What exactly does bounds checking enable us to do? It enables us to make sure that our input data is within an acceptable range for us. Let's assume that someday in the future somebody gets you a data set for you to analyze and present your analysis to them. You observe that there are a lot of issues with the data in terms of discrepancy in the values inside the data set. It's your duty to make sure that you do either of the following. You can either clean up the data provided you have sufficient information, or you need to get back to the person who requested you to do the analysis, letting them know that their data has a lot of discrepancies and that they should go back and fix the data. So what do we learn out of going through problems 4 and 5 here? The key aspect in both of these problems is that sometimes we skip steps. So that's going to be the first exception for in order execution. That's something which is called as conditional. So what exactly does a conditional enable you to do? Sometimes it enables you to do this step, or some other times it enables you to do that step. That's precisely what we saw in problem number 4 here, right? Depending on what you started with in the Xbox, you'll either do step 1 or not do it. So that's why I wrote the description down for the conditional as this or that. The next problem that I want you to go through is problem number 2. Pause the lecture video here and go through problem number 2. So if you ended up with 64 in the outbox, then you had the correct answer for problem number 2 here. So let's go through this particular problem. So the first code step here says put 1 in the outbox. So we initially start with 1. And then step number 2 here says multiply the value in the outbox by the value in the inbox. So you're going to get 4. Step number 3 says multiply the value in the outbox by the value in the inbox. So you're going to end up with 16. And then step 4 says multiply the value in the outbox by the value in the inbox. And you're going to end up with 64. I'm sure all of you noticed the redundancy that you saw in steps 3 and 4. You already have written down step 2. Can't you have a way for you to repeat a particular step n number of times? Let's say that you wanted to change the problem in such a way that you are able to repeat the number of steps not just thrice, but 10 times. Let's first talk about what exactly this code here is trying to achieve. Pause the lecture video here and think about it. You initially started with 4 and then you ended up with 64. If you have to do this 10 times, what do you think you'll end up with? So if your answer was that this particular code is trying to find power of 4, then you had the correct answer. Actually, let me rephrase that. My apologies. Instead of putting that down as power of 4, let me say that it's trying to cube 4 here. So you're just doing 4 to the power 3. So if you want to repeat the step 10 times, you'll be doing 4 to the power 10, correct? So this particular concept where you want to be able to repeat a certain step n times is called as the loop. So as you can see, this whole structure which I just drew near this step looks like a loop, hence the name loop. So loops are going to be the second exception for in-order execution. The loop enables you to perform a certain step in a repetitive way. That's going to be the objective for the loop here. So let's go to problem number 6 next. Go ahead and pause the lecture video here and go through problem number 6. So let's go through step number 1. Step number 1 says put 1 in total box. So let's go ahead and do that. Step number 2 says if n equals 1, skip to step 6. N is not equal to 1, so we can't skip to step 6. Otherwise, it says continue to step 3. And step 3 says multiply the value in total by the value in n. So you're going to end up with 4 here. So what are we doing then? It says multiply the value in total by the value in n and put the result back in total. My apologies. Let me backtrack slightly here. So going back to the previous step, it said put 1 in the total box. My apologies for that. And then we are checking if n is 1. N is not 1, so we are going to proceed with step 3. Step 3 says multiply the value in the total box by the value in n. So you're going to get 4 and put the result back in total. So you're going to end up with 4 in total. Looks like I did have the correct answer. My apologies. So what are we doing next? We are decreasing the value in n by 1. Whenever you're decreasing a certain value by 1, there is another term for it which is called as decrement. What do you think is the term for increasing a value by 1? If you thought of that as increment, then you had the correct answer to my question. Alright, so the next step is about decrementing the value of n by 1. So n is now going to be 3. And then next step says go to step 2. Go to step 2. Step 2 says if n is equal to 1, skip to step 6, n is not equal to 1. So you're going to do the same action. You're going to multiply total by the value of n. So you're going to end up with 12 here. And what are you going to do next? You're going to put the result back in total, which I already did. And then you're going to decrease the value in n by 1. So you're going to decrement n to 2. And after that you'll go back to step 2. N is still not 1. So you're going to multiply total by 2. So you're going to end up with 24. And then you'll decrement, looks like I touched the eraser by mistake. So I'll just repeat whatever we were doing. So we are going to increment 2 by 1. So you'll end up with 1. So after that you go back to step 2. In step 2 it says that if n is equal to 1, skip to step 6. So step 6 says copy the value in total to answer box. So the answer box is now going to contain 24. What do you think this code is doing? If you thought that the answer to this question was Fibonacci series, then you had what am I thinking? Factorial. My bad, something is off with this particular example. If you were thinking factorial as the answer, then you had the correct answer. So what exactly is factorial? 4 factorial is 4 into 3 into 2 into 1, correct? That's exactly what this particular algorithm enabled us to do. So what would happen if we had started with n at -1? Pause the lecture video here and think about what would happen if you initially started with n as -1. The unfortunate answer to that question is that your code will run forever, correct? Because you started with -1, your n value will never become 1, so you'll never go to step 6. You'll be constantly decrementing your n value. Whenever this happens, one thing is definitely guaranteed. At some point your program is supposed to crash. The difficult thing with certain programming languages is that it might take forever for your program to actually crash when such a thing happens. Are you able to recall how you can stop the program's execution based on one of the keyboard shortcuts that I taught you in the terminal lecture? Pause the lecture video here and think about what keyboard shortcut will enable you to do that. If you were thinking Control-C, then you had the correct answer to my question. So let's go ahead and talk about the last exception to in-order execution. I'm just going to state the exception and then I'll pause this lecture video and I'll record the actual exception problem in the next video. So the final exception is going to be what are called as functions. Functions are nothing but mini programs which enable you to perform a specific task within your program. I'll go ahead and wrap up this video here. We'll get started with the function problem soon.